Hello, today I'm going to be talking to you about radicals. We're actually going to cover lessons 4 and 5 in your workbook under radicals. So please turn to lesson 4 and we're actually going to scroll down or go past the first section here and go right to square roots. So when we're talking about square roots, the normal root symbol we often call it actually the principal root system, principal square root, and that's when we don't actually write the little 2 in. So that's when there's the hidden number 2. So if there's no number, we would pretend that there's a 2. Some of you may remember that we call that little number, that is our index. So when I'm talking about square roots, remember there's also always the positive and negative. So the square roots of 16 are 4 and negative 4. The reason why is negative 4 times negative 4 brings us back to 16, just like 4 times 4 brings us to 16. Sometimes you could see that the square root of 16 written like this, positive and negative 4, instead of writing it out separately like they've done there. I'm going to skip around a little bit here. So we're going to skip lesson 2 or example 2 and 3, and let's go to cube roots. So cube roots, here's a bunch of examples here. You should probably be recognizing now the first 5 of those. You might not have them memorized, but once I say them, it's making a little bit more sense. So the cubic root, our index on cubic roots is a little 3. We can take a negative cubic root of a number because when I have 3 negatives times each other, they bring us back to a negative answer. So you can have a cubic root of a negative, but you cannot have a square root of a negative. Again, I'm going to skip through a couple of these. Absolute value is something, if you'd like, you can read through this section. We're not going to cover it explicitly though. So now I'm going to turn to lesson 5 in our workbooks. So that was just a little bit of review. We're going to skip over the first section. So I should have reviewed with you in our last unit, but you can do on your calculator different roots. So if everyone takes out their graphing calculators, and I'll show you how to type in, for example, the 4th root of 10,000. So the first thing we're going to do, let's clear everything. You type in what your index is going to be, or what that little number is going to be. So in this case, it's a 4. Then you press math, and you're going to go down to the 5th one where there's that x root. And then you type in what the radicand, or the number you're taking the root of, is. So in this case, it's 10,000. Enter, and we get 10. Lovely. I want you to try this on your own for class example 2. Go through each one of them. A couple hints. Make sure you put a negative symbol instead of a subtraction symbol. On ones like this, where there's a number out front, that's multiplication between. So really it's saying negative 3 times the 4th root of 50,625. Okay, so pause the video, try all 4 of these, and then once you're done, press play again and my answers will be there for you. So there you have it. Those are entering them. For on C, you could do that in 1 step or multiple steps. I just showed you in multiple steps. I'm going to skip class example 3. So radicals, this is just a quick review of what a radical is again. So remember, the whole thing when that root symbol is there is called a radical. Our little number is called our index. And the number you're actually rooting is the radicand. So we'll go through these examples really quick. So in this first one, our index is 5. 75 is our radicand. When there's not a number written, the index is a 2, radicand is 50. Index 3, radicand is negative 1/10. That is being multiplied by the 5. So this next portion, I'm going to go over a little bit more detail. So it's really important that we're remembering these rules. So when I'm multiplying 2 radicals together that have the same root, you could write it in this form. So the root of A times the root of B is equal to the root of AB times each other. And they gave us an example here with the 9 and a 4. The same idea can be written for division. So you could write it out like that. This does not work, super important, does not work for addition and subtraction. And it also has to be the same index. That's really important with these pieces. It has to be the same index. Okay, so let's go to class example 5. So root 3 times root 6, is that the same thing as root 18? So we know 3 times 6 is 18, so that is most definitely true. On B, I could write this as 20 over 10, which is then the square root of 2, also true. We have addition here, so this is not true. That does not pass the test, that does not work. If you want to, plug into your calculator and see. You'll see those two values don't work. Actually, this one you could do even without a calculator. 16 plus 9 is 25. The square root of 25 is 5. The square root of 16 is 4. Square root of 9 is 3. 4 plus 3 is 7. Those are not equal to each other. Class example 6, write the following as a single radical in that form. So we're using this same idea. So now I have the square root of 8 times 3. So our final answer is 24. Let's just do this multiplication on the next one. 7 times 3 is 21. I'm showing a middle step here. If you want, you could skip this step and go straight to the square root of 5. This next one's a little bit tricky. So we have a couple roots going on here right now. The square root of 100, let's do that piece first. So it's like there's an imaginary or a hidden bracket on this piece. So the square root of 100 is 10. We still have that original root there, and then this is over 2. Well, now I can write this as 10 over 2, which is then the square root of 5. You kind of have to break this one into those pieces is because I have this double root happening here initially. Okay, now it says write these as a product of radicals. Product is the answer to a multiplication statement. So 77, two numbers I can multiply to get to 77 would be 7 and 11. 27, again, there could be multiple answers here. 27, I could use the square root of 9 times the square root of 3. 40, we could use the square root of 4 times the square root of 10. Right? There's a few different ones for those, but those are things you could use. And then we're done. So from this lesson, I want you to complete the practice questions. If you have any questions, stop and contact your teacher.